Hello everybody, this is SF Text. This is our first inaugural meetup. We're on location at VigLink in San Francisco, and one of our speakers tonight is Grant Ingersoll, the CTO of Lucidworks, the company behind Solr and Lucene. And as many of you know, Lucene is mostly widely used and deployed open source search engine. Almost every company which wants to have search on their site has Lucene somewhere. I want to ask, first of all, welcome, Grant.
Thank you. Glad to be here.
I think search is a common theme in all kind of text applications, and our general theme is text. Everybody needs to find some text they're looking for. First, I want to ask you, how did you come to Lucene and Solr in the first place, and how this interest evolved over several years to become a company? What's the trajectory?
Yeah, no, it's a great question. I mean, I think you're dead on that Lucene and Solr have grown so much. My personal history is I used to live up in Syracuse, New York, and if anybody's familiar with that, they know Syracuse University, which Dr. Elizabeth Liddy, who is a pretty big name in the text and natural language processing field. She had a company there called TextWise, which happened to have a job when I was looking for a job. I'd never done text in college or anything like that. Got hired to build a cross-language search system between English, French, German, Spanish, and Japanese. We used Oracle Context Search. This is back in like 1999, I believe. So that was kind of my first foray into search and NLP. Flash forward to 2004, I had left TextWise, went off and did some other stuff, and then came back to work for Liz again at the university this time in a place called the Center for Natural Language Processing. I was hired to build an English-Arabic cross-language search system this time. You can guess who was paying for that.
Right.
And I walked in the door, and my boss said, hey, we use this thing called Lucene. I said, great, let me go look up what that is. And started playing around with it as I started building out this system. Realized that I needed some things in Lucene that weren't there. Started submitting patches, and kind of the rest is history, if you will. Flash forward to 2007, founded Lucidworks around the premise of commercializing the capabilities around Solr and Lucene and providing product and all of that kind of on top of it. And of course, it's all exploded since then as well. So a lot of luck, right place, right time, and a bunch of hard work as well. But
that's great. Yeah, I remember, I think I first saw your talk at Hadoop Summit in 2012. And that was already in the business context, and you basically outlined big picture and big components of big data. So it's clearly, when people think big data, Solr Lucene comes up now. And so I wonder, how do you go from Lucene, which runs on a single node, to Solr, and what is the landscape in terms of distributed systems, and how do you see that area evolve?
Yeah, no, it's really been interesting over the years because, I think with Lucene, obviously it's just a set of Java APIs, and that provides search functionality, things like obviously matching queries and doing fuzzy matching and all that kind of stuff, as well as like language analyzers and then a whole bunch of modules that kind of help you build a kit of parts to build a search application. Along came Solr and really kind of said, all right, well, let's put this in a service layer and let's make it easy for people to interact with it. In the very early days of Solr, the scaling primarily was in a replicated model for query volume, because essentially, nobody really had really large-scale problems other than, the internet search people like Google and Bing and the like, because they were, and of course, they were building their own. So, especially in the e-commerce environment, it's just, hey, I've got a lot of queries, but I don't have a big index, so let's just replicate it. And then, flash forward a few more years as Hadoop's taking off, which, of course, Hadoop started as part of the Lucene project as well, was, okay, well, we now need to scale search to match those kinds of needs as well. So not only do we need to scale for query volume, but we also need to scale for a number of documents. And so, a lot of people had rolled their own using Solr and Lucene over the years. And so, one of the things that we really focused on as a company was, let's make sure that Solr just has really good distributed search capabilities out of the box. Solr Cloud was born. For whatever reason, I don't know the naming of it, but that was kind of the way we attacked it. Added in at first distributed search capabilities. You had to do the indexing yourself, and then with Solr 4.0, which was, I don't know, a year and a half, 2 years ago now, added the capability to do all the indexing and all of that as well, such that, I think I was at a meetup just recently up at Salesforce in Seattle. I think they announced their Solr deployment, somewhere 200, 300 billion documents in it, so people doing really large scale search, across, hundreds of billions of documents. It's only a matter of time before I'm sure we're doing trillions. And so, you're seeing just this massive uptake. And I think the other interesting thing is people are asking more interesting questions of their search engine as well. It's not just, hey, find me keywords and get back results. It's bring in all kinds of different data structures, numbers, spatial, enumerated types. How do I slice and dice that and bring me back what's important, right? Ultimately, shifting from it just being kind of traditional keyword search to being all about what's important in my data.
Yes.
And then, sifting through, using that to then power your downstream applications.
Yes, this actually connects very well with one of the themes of our meetup, because we see text as emerging again as a window into human intent, right? Through this little box, and this is how we're used to do search. But now, if you go to Google and you enter SFO BOS, it will give you tickets probably from San Francisco to Boston, or more structured data, and essentially search engine's ultimate goal is to figure out what was our original intent behind the query. So here, of course, I want to ask how we open source people are going to compete with the big guys, right? Because we have open source, we have the community, but the kind of structured data people want to ask may have semantic content, and how do we kind of map this more with structured data, which you mentioned? How do we kind of uncover more behind, more in our documents? What do you think is going to happen here in the open source in the next few years?
Wow, that's a lot of good questions in there. I mean, I think, obviously I can't predict the future, but, what you're seeing in open source, I think in the, kind of the early days, especially when I started with open source was primarily focused on commoditizing what people were seeing in the proprietary landscape, or they just got tired of building the same thing every time they went to a different company. So they said, the forward-thinking people were able to say, let's open source this such that I can carry it with me. Whereas nowadays, I think you're starting to see just a lot more innovation happening right in open source out of the box, as opposed to having, being cooked up in some lab somewhere. It's now being done in open source. That being said, I think that especially on the NLP side of things, it's still a little bit trailing, obviously. There's a lot of good new projects out there. The biggest challenge for open source, I think, when it comes to NLP, not so much search, but NLP, is just having the sheer amount of data and being able, as an open source community, to deal with the petabytes of data that can feed into the really large scale models that you're going to build around, whether that's machine translation or question answering or whatever it is. That takes a lot of effort and a lot of compute capabilities, and as open source community, you kind of have to beg and borrow to get that kind of stuff together, right? So those are, I think, some of the big challenges on the open source side. That being said, there's just a lot of interesting projects out there with NLP, such that, for a long time, I would always say, oh, well, NLP is great and I love working on it, but put it in practice is really challenging, and it demos very well, but it doesn't always perform very well. Whereas I think in, say the last, 3 to 5 years, maybe even less, you're really starting to see really large-scale practical applications where people are leveraging NLP on a daily basis, and it's becoming natural, whether that's on your phone or on a website, whatever. You're able to interact with the machine in a natural way, speak the language, right? The other interesting thing, I think, is, a lot of people talk, your question about structured and unstructured. It's one of my pet peeve terms, because I actually hate the word unstructured when it comes to text. And the reason why is, if you think about it, right, text is one of the most highly structured things we have, right? We're just not very good at telling the computer what that structure is and letting the computer take advantage of those things.
The grammar and the syntax and
dealing with the
else.
grammars and the relationships and all of those kinds of things, and the ambiguity. That's, I think, one of the cool things that's been happening as well, is more and more capabilities are coming around that make that easier to deal with, right? And obviously, you know, more universities are teaching this kind of stuff. More people are feeling comfortable dealing with probabilities and statistics as opposed to, you know, just kind of the pure relational models that, you know, probably you and I were trained on way back when we were undergrads. And so I think, you know, as you get that comfort level raised, as the open source gets better, that raises the bar for everybody. And that's kind of, you know, in my book, Taming Text, to try to address that kind of crowd of people who are new to all this stuff. How do I start to deal with the fact that I may not get the same answer every time I ask the question, right? Because the data's changed, or because there's some fuzziness in there that, you know, I haven't accounted for.
By the way, you know, Taming Text is a great book. Actually, Tom Morton and I were in the same PhD program at Penn, and kind of he still is there working for Comcast. So this is interesting connection, and I actually enjoyed it. I wonder, it's a very useful book, and it's a good primer on text processing. So I wonder, so in terms of scale, right? So I was at the 2007 Machine Translation Summit, where Google Translate talked for the first time, and Franz Ock presented the model, and he said, it's very simple. If you want real accurate translation, let's just collect several trillion words, and let's just do 7 grams, right? And that's essentially, that's how you solve this problem. So I wonder...
It's a small problem.
That's right. So I wonder, given the scale you mentioned, that Salesforce deployment, can I do a 7-gram model of several trillion words with Solr Lucene?
7 trillion words, and I mean, I think you can. Well, I mean, it's obviously going to take a lot of hardware. There's a lot more involved than just the pure programming side of that problem in Solr, right?
Yes.
You know, there's certainly people who, you know, you would have very, very large indexes, and you know, we've worked really hard in the community to make sure we can scale to very large sizes. Can we do 7 trillion 7 grams, or a trillion 7 grams?
Several trillion words and 7 grams.
You know, give me enough hardware, I'll get you there. I don't know right offhand. I would think we could get in that range, though, that it would be interesting. You know, and certainly when you bring in tools like Hadoop and Spark and that kind of stuff, you know, very complementary, you know, go off and do the really large scale stuff in an approach like that. And then, you know, you're reducing it down into something that is more manageable, and then use search to kind of access that and you know, query around it and slice and dice it in different ways in a more real-time approach, right? But yeah, no, I mean, I don't know. Do you have a big enough budget for us to do?
I'm just interested in the kind of scale, because, you know, here in the Salesforce size, I think that's very. I think it's getting really there, where, you know, big guys are playing. So I'm curious. About I know that your technology side is very rigorous, and I was really impressed by the fact that you guys are running your own Jepsen tests, right? So Jepsen is this distributed system testing suite, which is basically an integration test, which it tests, you know, all kinds of failure scenarios. So and it was done as a series of studies, but Lucidworks maintains its own Jepsen test suite. So I wonder, and apparently it shows that you guys are really paying attention to all kinds of error scenarios. I wonder, how do you make sure that the customers are not losing data? And you know, how do you, like, what kind of tools do you have, and what kind of scenarios do you see around this?
Right. Well, this is, you know, I mean, obviously the Jepsen work, I'm happy to get into. I mean, I think this is one of the beauties of the open source, is not just commoditization of functionality, but commoditization of test across a large number of people. When you're the most widely deployed search technology on the planet, right, you get a lot of people kicking the tires and coming up with error scenarios and all of those kinds of things, such that it gets to be, you get a lot of great feedback from the community at the quality assurance level. So, you've got that layer. Then we as a company, we look at where are areas that we can fund efforts around making sure that, we can leverage the community stuff and then feedback our own capabilities. The Jepsen thing was definitely an area of interest. We already knew like Solr and Solr Cloud was very robust and very mature. And, to some extent, we needed to just simply prove it by going through, essentially what Jepsen does is simulate network partitions, disk failure, hardware failure, all of these kinds of things in a nice self-contained way such that you can test whether you have data loss. Because one of the big things, we have companies who run their whole business off of Solr, right? So data loss is a huge problem for them if it happens, right? And so, in fact, where they're actually using Solr as the authoritative store for their data, right? So we've got to make sure that it's rock solid under all conditions. Now, obviously, no software is perfect, but so we want to make sure that we take a lot of, put in a lot of effort to make sure that we're doing those things. The Jepsen example is a great one of, actually one of our engineers, one of the things that people often talk about with Solr Cloud is, I've got this extra thing that's called Zookeeper, and that makes me have to do a little bit extra work. One of the things we wanted to do is show why that was such an advantage, because okay, you've got this extra process, but the thing that you get out of that now is, okay, it's a little bit harder to start, but would you rather have or easier to start or easier to finish? I don't know about you, I would rather have my weekends when the system is up and in production and all of that kind of stuff, then a little extra work to set up Zookeeper up front because, oh, by the way, it's not that hard anyways. So we as a company wanted to showcase why we chose Zookeeper as the distributed coordination service for Solr and show and demonstrate very cleanly, especially compared to our competition, of how you can avoid things like split brain scenarios, network partitions, data loss, by making a better decision about the robust, about the way you coordinate your distributed activities. So for people who don't care about data loss, then you don't necessarily care about Zookeeper. And don't get me wrong, there are use cases for that. If it's not your authoritative store, if you're just doing some data that you can throw away if it goes away, or you can just re-index, then maybe Zookeeper isn't your thing. But if you're going to run your business, if you're doing $2 billion a year in e-commerce and you need to handle massive scale at Christmas time or the holiday season, you can't afford to have data loss. You can't afford to have the kinds of problems that Zookeeper helps you avoid. So gladly pay that cost because it's going to save you in the long run. Right.
It's great to hear this. I mean, I come from a distributed systems community where we use Scala and Spark and Akka and tools like that. So, and Mesos and Aurora, of course, and all these things. And so it counts, goes without saying what kind of benefits you derive from Zookeeper. But apparently, it's the knowledge kind of spreading through communities at different speed. So it's great to hear that you guys rely on this as a proven technology, right? Which is designed to actually enable this. So you mentioned Spark, and since I also organize SF Scala meetup and co-organize the Spark meetup, I got to ask about this. So how do you guys interoperate with Scala and Spark? And given that Spark now runs on top of almost any distributed system, should I be able to run Spark on top of Solr, for instance, and open up a bunch of readers, read a bunch of stuff in, and kind of do something there?
Have you been listening in on our meetings at work, at Lucidworks? No, I mean, that's a great question. We just recently actually published Solr Spark integration. It's up on our Lucidworks GitHub page. So if you go just do Lucidworks GitHub, you'll find a Spark Solr integration there, all open source, Apache licensed. And so that's kind of one level. That's essentially about how do I interact with getting data in and out of Solr into Spark and vice versa, right? So that's kind of the one level of thing. The other level is actually in our commercial product called Lucidworks Fusion. We are in the process of bringing in, so we, with Fusion, we do a lot of things about signal capture. There's things like clickstream analysis, all of that, and then churn that back into relevance, back into relevance gold, if you will. So if you take all of the click information that you're getting, then churn that back around into better search results, right? So we do a lot of that in Solr. right? Just out of the box, and we can query Solr in the right way such that we can do things like recommendation engines right out of Solr, collaborative filtering, all that kind of stuff. Where it then gets interesting is essentially those are all like aggregation problems, right? Or building up models, and they often require large-scale batch, style compute. This is where Spark comes in, as if in the truly large cases where we have, you're doing millions and millions of events an hour or a day, et cetera, and you get a really large, essentially matrix. Spark is a great place to come in and do that machine learning work where you're building a model in Spark, and then you plug it back in, works seamlessly with Fusion, and then you can go and query that model. So if you're building a classification model, or if you're building a recommender, et cetera, we can tie that all in together. And so that's going to be part of our product here very soon as well. So yeah, we love Spark. We did MapReduce for a long time, saw the shortcomings. Another project I'm involved with, Mahout, that's all been switching over to Spark and Scala as well. I'm not as deeply involved there as I once was, but a lot of great work there about bringing more machine learning capabilities into Scala and into Spark. There's some really nice, there's a really nice DSL in there for building generalized linear models now. And leverages Scala underneath the hood and makes it super easy for people to build out those kinds of things, build your models. And that's all Spark and Scala underneath the hood, as I understand it. So, I myself am not a Scala person, but, we do see it in a lot of different places and have some of it within the company as well. So
that's great to hear, because I can tell you, as kind of as a developer who builds systems, which use both search and NLP machine learning and extraction. I think Solr and Spark make an ideal combination because, for instance, if I'm on top of a database, I essentially have to think how I'm representing my textual data in the database, right? And you guys spend a lot of time thinking how you do that. Yeah. So essentially, for a lot of applications we're going to see discussed as of text, this makes actually a very good combination. So maybe, since you mentioned you guys are developing this, maybe I can ask you to come back and talk about it when you guys are developing it, because that's certainly a great combination of technologies. So, and the last question I want to ask you, I think you really present an interesting path in open source because you're the guy who interested in specific technology, masters it very deeply and specifically with Lucene, and then you turn it into a successful business, right? Which is basically used by a lot of people all over the world. So what kind of advice do you have to open source people who want to do the same? There is a lot of folks, especially in the technology area, who develop tools. What are the important things you have to pay attention to if you want to, take an important open source technology and make a business out of it?
Wow, that's a great question. I think there's a lot of lessons learned across so many things. Building a business is so much more than just the technology, right? And open source as a business model has a lot of great things and a lot of challenges as well, right? In terms of, you've got, for us it was interesting, very early on, we were like, we can just go put out our welcome mat and people will come to us for Solr support. And the break fix, hey, I need insurance, for instance, for my search engine, right? And we still do a lot of that business, but what's interesting is that Solr doesn't break. And so people are like, hey, that's great, we love Solr, but come renewal time, hey, I already know when it works and I haven't had any trouble. And so one of the interesting things that we've evolved into is you've got to have capabilities on top of that. So when we think about how we engage with our customers, we've shifted very much to what we call a customer success model, which is, hey, we're going to be there for the break fix, that's one thing. But in reality, what customers kept coming to us for is help me understand the difficult problems better. You guys are experts in search. You know machine learning. You know natural language processing. Help me with product in terms of tools that make my life easier to do those things. But then also, hey, how do I make this better? How do I have better relevance, for instance? How do I scale this? How do I grow with my business? How do I ask more interesting questions of my data? And so what the customer success model that we've put in place, like I said, obviously has the break fix, but is also really geared towards making sure customers can grow and be successful together with us. So, open source is one part of the business decision, is should I put my technology out in the open? And everybody's going to be different there. But I think one of the things that you have to think about is this technology something that has a big enough base that I can actually build a company around? Obviously, it's got to be more than just your pet project or you and your buddy's pet project. And it's not enough just to show up and say, okay, well, hey, I've got, kind of open source kind of goes through these phases of, it's a couple of guys or a couple of people together working on something that's of interest to them. And then it usually evolves to where you can kind of support an ecosystem of one-off consultants who can come and say, hey, I can help you with your hard problem. And then, it gets to the likes of the Hadoops and the Sparks and the Solrs, et cetera, where you can sustain multiple businesses around it, and they all contribute back to the core, but they all have presumably their unique differentiator. And I think depending on where that project is in its lifespan will determine how you can go about commercializing open source technology. The other thing is you just always have to keep investing in the open source, and there's always this kind of delicate balancing act of, at the end of the day, you have to, quote unquote, put food on the table. You have to pay salaries, you got to keep the lights on, et cetera. So there's something that you have to be, that you have to be able to monetize. But at the same time, the community pressure is often, how do I want all of this for free. They want your time for free, they want your code for free, et cetera. So you have to kind of work together to come up with a win-win situation for everybody, such that the community is benefiting as well as you're able to pay salaries and all that kind of stuff.
And there is a good balance between contributions from the outside community and the company employees.
And so for us, as a company, we look at how we can complement and extend Solr. We still invest a lot in core Solr. I think we're the single largest contributor to Solr in the community. But then we also look at, from a product standpoint, is what things do we know customers want that the community doesn't do. So for instance, Solr itself doesn't do connectors to crawl the web or connect to Twitter or SharePoint or whatever file system repository there is out there. So that's a gap that we fill as a company, right? Or Solr is primarily made up of developers who are focused on the back end, algorithms and core search functionality. They don't really care about search UI. So we come in and bring user interfaces to the customers that allow them to work with Solr without having to necessarily write Java code, right?
Yeah. And they probably care about the UI, but not about building the UI.
Exactly. Yeah. And then the other part of how we are with Solr really is, how do we ask more interesting questions of Solr? So we want to drive more data into Solr such that we can ask more interesting questions of it. So again, it's kind of that complement and extend model of open source, if you will, that I think has worked well for us, and we're continuing to invest a lot in that way of doing things.
Oh, that's great. I think